Good afternoon, this is Kavi Priya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic capacitance. So I am going to discuss about the spherical and the cylindrical capacitor. So these are the flow of my presentation. I am going to discuss about the spherical capacitance, cylindrical capacitance, their physical significance, and finally about the applications. Before starting with the discussion, let's recall about the introduction to capacitance and the parallel plate capacitance, what we have discussed in the last session. So capacitance is a storage element which is capable of storing the energy in the electric field. In case of parallel plate capacitance, two parallel plates, two conducting plates will be separated by a dielectric medium. The capacitance equation is given as C is equal to epsilon into A divided by D. Epsilon is a permittivity, A is the area between the plates, and D is the distance of separation between the plates. So the factors that affects a capacitance are permittivity, area of the plates, and distance of separation between the plates. First, let's start with the cylindrical and spherical capacitance, where it is being used. It is used in the coaxial cables, it is used in the underground power cables, and it is used in the isolated charge pairs. So let's start with the cylindrical capacitance. Here we'll be having two coaxial conducting cylinders. So we'll be having an inner cylinder and we'll be having an outer cylinder. So we are considering the inner cylinder radius as A and the outer cylinder radius as a B. So these two cylinders will be separated by a dielectric medium. Okay, and the L is the length of the cylinder. So L will be always greater when compared to the outer cylinder radius. Here the capacitance equation is given as C is equal to 2 pi epsilon L divided by ln of B by A, where L is the length of the cylinder, B is the radius of the outer cylinder, and A is the radius of the inner cylinder. And we all know the equation for this epsilon, which is nothing but epsilon naught into epsilon R. And next one is a spherical capacitor. Here we'll be having two concentric spheres, two concentric conducting spheres, inner sphere, outer sphere. Inner sphere radius is small a and outer sphere radius is small b. We are considering like that. Actually, we can take it as any notation. We are taking it as a and b over here. And the capacitance C is equal to 4 pi epsilon AB by B minus A. So we have two concentric spheres and the distance, the area between the two spheres is filled with a dielectric medium. So the equation, under the equation we have this epsilon, which is a permittivity, A is the inner sphere radius, B is the outer sphere radius, and 4 pi epsilon AB by B minus A is the equation for the capacitance in case of the spherical capacitor. And next one is a curiosity challenge. What is the odd man out among four? Coaxial cable, high voltage equipment, electrostatic shielding, and audio amplifier. So D is the odd man out. It is not a capaciting one. It deals with the amplification part. And next riddle. I follow inverse square law. My symmetry is a perfect round used where high voltage is found, which is nothing but it is a spherical capacitor. So since it is represented as a perfect round, the answer for this riddle is a spherical capacitor. And next one is the physical significance of the capacitance. So in case of the cylindrical and spherical, it depends on the capacitance depends on the length of the cylinder in case of the cylindrical capacitance and the ratio of radii in case of the spherical capacitance as well as the cylindrical capacitance, and it also depends upon the dielectric medium which is being filled between the cylinders in case of the cylindrical capacitance, in between the sphere in case of the spherical capacitance. And next one is the application of the cylindrical and spherical. Cylindrical is being used in the high voltage cable. It is used in the RF coaxial cable. It is used in high frequency tuning circuits. And it is used in pulse power systems. Where spherical is being used in the scientific equipments. It is used in the electrostatic shields. And it is being used in the satellite equipments as well. And this is a summary of what we have discussed so far. In general, we have discussed about this introduction for capacitance and as well as the parallel plate, and later we have discussed about the cylindrical, spherical capacitance, and what are the factors that affects the capacitance in case of the cylindrical and spherical. And finally, we have discussed about the applications of the cylindrical and spherical capacitance. And these are all my references. And next one is the assessment. For spherical capacitance, the capacitance depends on the radii of inner and the outer sphere, which is a typical application of a cylindrical capacitor, which is a coaxial cable. It is being used in the coaxial cable. Thank you all. Thank you.